Hello everyone, welcome to my new video. This video will show you about what is engineering drawing. Engineering drawing can be defined as a graphical language used by engineers and other technical personnel associated with the engineering profession. It fully and clearly describe the requirement for engineer item. Engineering drawing is a two-dimensional representation of a three-dimensional object. In other words, engineering drawing is the art of correctly representing a real or imaginary object on paper. In this process, we would use some graphic symbol, letter, and number with the aid of engineering drawing. Instrument. The object can be building road, machine, a cycle, edge. An engineering drawing provides all information about the object size, shape, surface, type, material, etc. It can be used in building drawing for civil engineering, machine drawing for mechanical engineer, circular diagram for electrical and electronic engineer at purpose of engineering drawing. Generally speaking, it is taught and complicated to explain some specific engineering requirement in world. In this case, an engineering drawing with good size and proper scale can make it easier for the technician to understand and execute the design intent. A single part engineering drawing gives a visual depiction of the part structure, dimension, and other requirement. A single part drawing is frequently used as the until of processing in the manufacturing industry. Besides, an engineer can use an assembly drawing to represent a machine or equipment assembled from multiple parts to take a multicolor function. Assembly drawing frequently used to confirm that the actual fabrication of individual parts fulfill assembly requirement. Application of engineering drawing. Engineering drawing is essential for technical people compared to verbal or written description. This method is brief and clear. Engineering drawing is a critical part of almost all engineering projects. We can find that engineering drawing so many critical applications. 1. It's used in ship for navigation. 2. For manufacturing of machine automobile. 3. For the construction of building, road, bridge, dam, electrical and telecommunication structure. 4. For manufacturing electric applications like TV, phone, computer. 8. Type of engineering drawing. Engineering drawing can be grouped into 4 major categories: geometrical drawing, mechanical engineering drawing, civil engineering drawing, and electrical and electronic engineering drawing. Geometric drawing. Geometric drawing is the art of representing geometric objects on paper such as rectangle, square, cube, cone, cylinder, sphere, and so on. Geometric drawing can be divided into plane geometrical drawing and solid geometrical drawing. Suppose the object has only two dimensions, i.e. length and breadth, as rectangle, sphere, triangle, and so on. In that case, it called plane geometrical drawing. It is called a solid geometrical drawing if the object has three dimensions, i.e. length, breadth, and thickness, depth, a cube, bridge, sphere, cylinder, and so on. Mechanical engineering drawing. Mechanical engineering drawing is the art of representing mechanical engineering objects on paper such as machine part, and so on. Mechanical engineers use it to express mechanical engineering work and project. For actual execution, civil engineering drawing. Civil engineering drawing is the art of representing civil engineering objects on paper, such as building, road, bridge, dam, etc. Civil engineers use it to express civil engineering works and projects for actual execution. Electrical and electronic engineering drawing. Electrical and electronic engineering drawing is the art of representing electrical engineering object or electronic circle on paper, such as a motor, generator, transformer, wiring, diagram, TV, phone, computer at electronic engineer use it to express electronic engineering works and project for actual execution. Method of making engineering drawing. Manual drawing and computer drawing are the two common methods of making engineering drawing. Manual drawing has been the primary engineering drawing method for the past few decades. People would use various tools to draw by hand, such as drawing board, paper, ruler, caliper, round, gags, and but the manual drawing process is very tedious and uh, unsuitable for contemporary manufacturing in pursuit of efficiency. Computer drawing is more popular with contemporary manufacturer. It eliminates the tedious process of manual drawing and allow different versions of the design to be retained. Computer drawing is commonly used in CAD, computer aided design software. You can use CAD to create drawing from scratch. However, we recommend developing a 3D model and then making the drawing from it. The program generates the view with just a few clicks. You need to add the dimension, which save time and effort. Basic component of an engineering drawing. A single drawing includes several elements with quite a few verifications to each item. Let's take a closer look at the basic component of an engineering drawing so you can learn how to read engineering drawing. Type of line in engineering drawing. Take note that all of the lines on an engineering drawing are equal. Various options are available for showing both hidden and visible edge of part. Continue line. The most common line type is a continuous line, often called a drawing line. It represents an object physical boundaries. Simply put, a continuous line so to draw the object, the line thickness varies. The inner line are thinner while the outer contact use thickness line. Center line. The center line can show the part with whole and symmetrical feature. Symmetry can reduce the number of dimensions in a drawing while also making it more visually appealing and easier to understand for the reader. Hidden line. The hidden line is another type of line used in mechanical drawing. It can show something that could not be otherwise visible on the drawing. For example, the hidden line can show the length of an entire step on a path without using a section or cut out view. Yeah, see example. Hidden line. This is the photo or example. Dimension and extension line. The extension line describes the object being measured. The dimension line contains two arrowheads between the extension line and the measurement above or inside the line. This is the example. Dimension and extension line. A broken view line. Using a broken view line means that a view has been broken. If you have a 3000 millimeter long and 10 millimeter wide part with symmetric quality, using a brick now offer you all the information without taking up as much space. Cutting plane line. The cutting plane line display the cut out trajectory using a cutout view. Sent to a cutting line, you can see the both tape or hole are visible here. Tape of view. An engineering drawing contains numerous tape of view. Those views all perform distinct function. Adding a view should follow the same logic as dimensioning. Note that you should only add a view that contributes to the overall comprehension of the design. Orthographic view. This is the photo example. Yeah, they call orthographic view. Very nice. The orthographic view is the core of an engineering drawing. An orthographic view or orthographic projection is an approach to depicting a 3D object in 2D. As a result, a 2D view must convey all information required for part manufacturer. This approach of representation allows for the avoidance of length distortion. We can use three different views in a multi-view drawing to convey all the information such as the front view, top view, and side view. It is conceivable that several extract views will be required to display all of the information. However, less is more. Isometric view. Isometric view. Isometric drawing depict three-dimensional part or vertical line remain vertical while parallel lines are present at a 30-degree angle. The length of the vertical and parallel line are true. Therefore, using a ruler and the drawing scaling, you may easily measure the length from a paper drawing. The same is not true for angle line. With this type of view, engineer adhere to the dimension instead of optical illusion. Section view. A section view can readily reveal some of the part characteristics that are not apparent at first glance. The cross section is preferable over hidden line because it provides greater clarity. The cross hatching feature is a cross sectional view indicator. Yes, this is the photo example. Very nice. Clearly. Section A to A. Yes. Detail view. The detail view provide a close-up of specific section. In a larger view, detail view is ideal when a hook part contains many vital dimensions in a small area. It is a good view of the readability of measurement. Yes. Cutout view. The cutout view has the same image used to show the section view, with one exception. The side view contains cutout. Cutout can have decreased the number of distinct view on a single drawing. As a result, we could easily delete the section view and add all required dimension to the cutout. Auxiliary view. The auxiliary view is an orthographic view to represent non-horizontal or non-vertical plane. It displays inclined surface without distortion. This is the example. Yes. Dimension. In some instance, CAD model may lack vital information such as GD and T and geometric dimensioning tolerance. The correct dimension can guarantee the path along the line with less maintenance, while you may automatically fit all dimension where the measure button. Adding engineering tolerance require manual intervention. Information block. Additional information is displayed in the little box in the bottom right corner. The title, block list, blacklist, blacklist, the author name, quantity, coding, part name, part number, scale it. The information block may also contain material price. It can be used better to understand all the part of the technical drawing. See the photo example. Very nice. Assembly drawing. The following point will help you better design assembly drawing and make your project in the machine shop more efficient. Keep in mind that the technical drawing aim to facilitate the assembly process. It should be clear where each part goes and how it attached to tools like general dimension, cut section view, number, pick and detail view for or close up. Make sure the bill of material has accurate information regarding part number, name and quantity. Common mistake in engineering drawing. There are 4 common mistakes in engineering drawing. 1. Dimension making is messy, complete, omitted and repeat. 1. About close dimension. 2. You must directly mark the critical dimension of the part. 3. Mark the size to make processing and measuring easier. The placement of view is inaccurate or they do not correspond with one another and the design intent is unclear. 3. If the box picked with high dimensional accuracy requirement is not marked with dimensional tolerance, it will cause significant machining error and the work pick will be scrapped. 4. Part technical requirements such as form tolerance, dimension tolerance and surface roughness are not marked standard decision. Eight tip for grading engineering drawing. The following 8 tips will teach you how to grade better engineering drawing that communication your critical need for the part while also saving you time and money. Uh, Tip 1, uh, dimension only critical and measurable feature. Tip 2, communicate whole tapping with thread size and deep. Tip 3, consolidate call out of multiple of the same feature exist in a view. Tip 4, communicate assembly intent of a crucial feature. Tip 5, providing part number and supplier for hardware installation. Tip 6, no need to include optional secondary operation call out on the drawing. Tip 7, avoid over dimension or over tolerance on your design. Tip 8, tolerance must fall within standard accuracy level. Yeah. Conclusion. An engineering drawing depict the information and requirement need to products to produce a given item or product. It is a graphic called language that convey short and information, not just a drawing. Clear engineering drawing design help your manufacturer product a functioning and aesthetically pleasing part that fulfill your needs. At least our experience engineer can analyze all aspects of engineering drawing to ensure you always receive the high quality machine part and get a free quote. Thank you very much for your time that you always support my video. Thank you very much. See you next video. Goodbye. Have a nice day.